webcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to the first in a series of webinars sponsored by HiQA. The Are You Ready for Your Future? Quality 4.0, the Next Generation Technology webinar series. Today's topic, how true automated ballooning and GD&T extraction can streamline your quality process. I want to take care of a few housekeeping items before we begin. The presentation is going to last approximately 45 to 50 minutes. We're going to have a Q&A session after the presentation as time permits, and any unaddressed questions during the session will be answered directly via email. I'd also like to ask you to please raise your hand and let me know if you can see and hear clearly. For those of you unaware, there's a little hand icon in the control panel that you can use. We're getting some people in now. Good. Feel free at any time to enter questions for the presenter in the questions box. And if you have any issues with your audio during the presentation, you can send the chat message to me and I will see what I can do to help you. Today's presenter is Sam Golan from HiQA. He's the founder and CEO. Sam's a serial entrepreneur with over 30 years experience in founding and building successful companies. He spent a lot of that time with numerous software companies supporting manufacturing industries with CAD/CAM, PLM, metrology, and IT areas. Sam, you ready to go?
I am ready to go.
All right.
And if I'll get the presentation right, I'm going to share my screen.
There you go.
Okay. And let me just make it in a large scale, and I hope you can see what I'm presenting here. I hope you can see my screen, guys. Raise your hand in case you don't, and Jack will let me know because I don't see your hands right now.
We can see the screen.
You can see. All right, thanks a lot. Okay, so Industry 4.0 or Quality 4.0 that we're gonna focus on, but it's all associated with Industry 4.0. When we look into those revolutions along the years, starting with Industry 1.0, it started on the 80s with water and steam-powered machine that developed to aid workers. As production capabilities increased because of those machines that powered by water and steam, also businesses started to grow from individuals, owners, taking care of their own family, maybe neighbors, to a real organization with owner, managers, employees, and started to serve customers. When we talk about the second revolution, it kind of at the beginning of the 20th century, when electricity became primary source of power. And then it was easier to use, of course, than water and steam. This enables businesses to concentrate power source to individual machines. Eventually, machines were designed with their own power source and making them more portable. Comes Industry 3.0 in the last few decades on the 20th century, the invention and the manufacture of electronic devices such as transistor and later on integrated circuit chips made it possible to more fully automated individual machines to supplement replacing operators. This period also spanned the development of software systems to capitalize on the electronic hardware. Well, with this, what we all know and we talk today created a pressure to reduce costs caused by many manufacturers, and they tried to move components and assembly operation to low-cost countries. The extended geographic distribution resulted in formalization of the concept of supply chain or supply chain management, which we try to do today, not very successfully yet. So what is Industry 4.0? Industry 4.0 started in the 21st century, connects all the Internet of Things, which we all know, which the IoT, with manufacturing techniques, which enable systems to share information, analyze it, use it, and guide it in more intelligent way. It also incorporates cutting-edge technology, including additive manufacturing, robotics, artificial intelligence, and other cognitive technologies, advanced material, and augmented reality. So when we look into this slide, you can see the whole aggregated components that develop across the Industry 4.0. Some of them created a little bit at the end of the 20th century, and some of them developed today. But the whole idea is always the same: reduce costs, use intelligent processes, control manufacturing, and better control supply chain. When we look into the supply chain, or Industry 4.0, usually called also a smart factory. A smart factory, which is, call it cyber physical system, monitor the physical processes of the factory, making or helping to decentralize decisions or knowledge center, like people and sometimes machine in vertical software activities or software solutions. The physical system become the Internet of the Things, as we all know, communicating and cooperating both with each other across the wireless and the web. So when we looking into the industry, the great news is that the manufacturing industry is booming. And as you see here, again, looking a couple of good years earlier, when the 737, I don't want to talk about the MAX, I'm talking about the 37 traditional, it has 400,000 parts, which was great for the supply chain. But when you jump a couple of good years ahead and you look on the Dreamliner, the 777, and now the 747 Series 8, we're talking about 6 million parts, which is huge. This is absolutely great news for the manufacturing industry. Same, we can talk about the automotive. If we look into the standard car that has 30,000 parts, and then when we jump from standard to hybrid, then the parts double. And when we go into the autonomous car, then we come 80,000 parts. So the next, I would say, at least 15 to 20 years, the manufacturing industry is going to go and grow and grow and grow. And that's huge opportunity. But with this come a big challenge. So Industry 4.0, why now? We all know that need and large manufacturers are looking to automate the processes. But when you look into the parts that we used to do 10, 15, 20 years ago, they are getting much smaller much more complicated, and we would like to save material. We don't want to have assembly line when you assemble a cell phone in 20 minutes instead of point click. Therefore, the requirements from the suppliers is getting more and more, I would say, complicated. There's a lot of data on a print, manufacturing requirements, and so on. Also, the product life cycle shrank. I mean, we are living in a replacement market. I mean, last time you replaced your phone, maybe it was like 6 months, 12 months, maybe 4 months ago. And we usually do not fix things today. We just buying new one. And that's great opportunity for the manufacturing industry. But on the other hand, putting a lot of pressure because OEMs does not want to have huge warehouse with parts, definitely with not a assembled product. They pressure for just in time. And for the manufacturing industry, just in time is another layer of pressure, of course. So again, another component or another angle to look into it, the manufacturing industry, when we talk about, I would say mid to large manufacturers, are applying automation, robotics, because they have to increase productivity. They put new software or IT solution in place because competition is growing. Everybody sees the opportunity in the manufacturing industry. So in that comes OEM demand to meet compliance regulation that are growing from day to day, talking about the aerospace industry, the defense industry, the medical industry. So it requires suppliers to be much more cooperative with their requirements, definitely require more transparency from supply chain. And as OEMs sees their suppliers as a critical component in their life, as such, they expect from the supplier to adopt technology quicker, apply automation. As the suppliers needs to be competitive, definitely OEM needs to be more competitive. So when we looking into Industry 4.0, which is in really advanced stage today, and we look into the quality 4.0, which we have to comply with and or synchronize with, looking on these slides, that it's like, hey, this is quality 4.0. I know these slides for 2 years, 5 years, and 10 years ago. Nothing changed in the quality area. But I think we have a much bigger challenge. When we look on this print we used to use 5 years ago, 20 years ago, 50 years ago, and talking about automation, we're still doing the same thing when we talk about 2D print. And 2D print, we still need to go and do our process manually today, extracting the data manually, putting the data in Excel manually, and it's very hard for the quality industry to synchronize with the Industry 4.0 with all the demand of automation, decentralization of knowledge. We don't have knowledge on a piece of paper. So what I would like to do in this minute, I would like to kind of quickly jump and share with you how really you can streamline the process when you have 2D print from what you probably used to do today and how it can be done differently. So I'm trying to jump here, and I hope that you can see my screen. And this is Inspection Manager. And I open in the Inspection Manager, not a complicated drawing. It's a 2D print. I wanted to put some kind of, call it a challenges GD&T into it. And I would assume that probably most of you, I don't want to say all, I don't know what you have, but needs to take this 2D print, manually balloon it, extracting the data, put it on Excel, and do the whole process like manually. then save it in different folders, different locations, then collecting data, copy the data, type the data, create inspection plan, and then first article or PPAP report. So probably you know all those things, but what I'm going to do here, just to give you the idea, in this system, when you click Auto Balloon, GD&T, and PMI, and of course we don't have time to do more deeper demonstration, but you have multiple options how to handle one page or multi-pages. When the system gets this OK button, it's actually the engine that developed, which is OCR, Optical Characteristic Recognition, or with artificial intelligence, actually dives into the drawing, understands all the quality requirements out of this 2D print. And this print, for all of us, it's a picture. It's a raster or it's a vector. With our eyes, we see it, but we are going now to digitize it in a way that we are going to extract all the data automatically out of this 2D print. Of course, we are going to balloon the print in parallel, but all the data will be in the database. So when we look into this print that has probably 30-some dimensions, I would assume that it's done today, I would say maybe 1.5 hours, maybe 2 hours. I'm not talking about balloon the print. I'm talking about extracting the data out of the print. And it's going to take here probably another few seconds. Can you see it, guys? I hope we do not have delays.
Yeah, we can see
Great.
it.
Great, thank you. So what you can see here now, all the print balloon automatically. This is not what I meant. Go back. Oh, here it is. We balloon the print automatically, and that's nice. But I believe that this is even nicer. As you see here, all the data that this print is supposed to share with us, and we do it manually on Excel, extracted actually completely automatically out of this 2D print. Okay? And there are multiple options, and I know that part of you or most of you, depends on what role they are making in their shop or job shop or another facility that you are coming from, may get different drawing with different quality. Here is a statement. There will be no drawing that you will not be able to accomplish here, no matter what. And we may have time, I may go over it, but what I would like to share with you now, to understand better what we did here, if you're gonna go here for, let's say, dimension 17, so to show you the intelligence, the depth of the system, dimension 17 actually represents 3 calls out for each hole that you see here. So we have 4 holes and 3 calls out per hole. If you look here down on the bill of characteristic, which is the database, you can see here 17.1, 17.2, and 17.3. So we broke down balloon 17 to exactly what it needs to represent. And if we look into the right side, you can see now we are standing on 17.1. It is highlighted red. That's the engine recognition. Show me what it's now. And then this is what goes into the database. So you can see 17.1 4 times goes into the database with the nominal and its tolerance. Okay? And you may ask yourself, hey, where is tolerance comes from? From here. And again, without jumping to a training, there is an option, of course, for you to go and generate your own tolerance table based on the drawing that you are getting, call it your by name, by customer name, and this is where you build your decimal table very easily and apply it on the drawing. And that's what I do. I pick the default, all those dimensions that has no GD&T, this default table apply to them automatically. Couple of other things I would like to share with you. And I mentioned the point that you may get drawing that it's not great, and we may miss dimension when we run the process, and I'm intentionally deleting one of the dimension, as you see here. And you may have very detailed drawing that has 300-400 dimension on it, and when you run the process, you firstly want to know, hey, maybe we missed one of the dimension. So one of the nice unique tool that we have here to find out what we missed by mistake the system. I have here the function called whiteout. I'm clicking on the whiteout, and now you can see exactly what was missed, because we know what we did not. So it's easy to white out what we didn't. So I can recover from this very quickly, clipping it here, as you see, and I'm now just and I can move the balloon wherever I want. If it bothers me, and I can box it like I'm doing here. And you can see on the right side, there will be a few seconds of unknown, and now it's known. And now it comes to the database as 1.5 with linear dimension. But it might be that because of the drawing quality is not linear. So you have the option, of course, here to say, no, it's not linear, it's diameter, it's not 1.5, I don't know, it may be 2.5. You just save it, and now it's in the database. So now you can see below here, diameter 2.5, and that's it. So don't afraid to get not great drawing. All you need to do in this right side, just fix it the way it looks, and you're all set. So I'm going to bring it back to where it's supposed to be. I'm going to save it. But you're probably going to ask yourself, well, now I have balloon 25. Why do I have it? Or can I renumber it? So my question divided into two parts. One, the system is smart enough and thinks that you may have an engineering change, and feature X deleted, feature Y added. I cannot use the balloon number from a deleted feature. But we didn't do any engineering change, so I have the ability, and I'm user, and it doesn't matter what permission I have, because we manage users and permission as an option. If I do not have admin right, then those lock, unlock, and all this function would be grayed out. But in this case, I didn't do any engineering change. I do auto renumber, and it comes back exactly where it's supposed to be. Okay? So there are other things that you can do here when we got into downstream preparation. I would assume that most of you, or maybe all of you, needs to report on notes. Notes, we do not balloon automatically. We just do it by clicking on the notes icon, and you can pick up 1 note, 2 notes, 5 notes, just capture them as I'm doing here. This is 1 note, and balloon added now to the note, as you see, 25, and it's added to my inspection plan below, or the bill of characteristics, as I pick them, right? So now we have 25 and 26. I need also, most probably, to handle my title block text, because I would like to have on my reports and in the database, I would like to have a real part name, not just file name, as you see on the right side, right? So now my part name is replaced with a full part name, not what I got from the file name. The same I will do is the revision. And again, you can type it, but I don't like to type, so I'm using my mouse. Another thing that you might be interested to handle at this stage is the part material, as you see here. And in the part material, which I'm picking it right now, you're going to see it here, also in my database on the right side. I believe you can see it, guys. And now, in part material, we may need to do more than just have this part material in the database. I can go here, and now you can see a lot of tabs that helps you to handle your process. Again, we don't need to dive, of course, into training, but we handle bill of material, MFG operations, sampling jobs. But in part material, what I would like just to show you, here is my material, but every time that you're going to see pencil, click on it, and much more data can be added. In our case, it's going to be material code, specification number, search, supplier. Who is my supplier for this part? For this material, sorry. Approval, download, comments, and then you can upload any data that relates to this material. If you have, by the way, 2 materials per part, just add another line and you're all set. So kind of in a nutshell, talking about drawings, and we may do much more into it. Maybe one thing I would like to share with you, we have a lot of customers, and I don't know if what the case is in your place, but we have customers that are handling 2 units. In this case, you see this is English, but we of course support dual units. But the problem is that you may get, unit A and you need to do conversion to unit B. In many cases, you get matrix. You're definitely going to do it matrix for your customer. But for internal process, people say, oh, we need to convert it to inches because my guys are not great with it and our inspection tools are in inches. So then what happens, calculators started to play. And we say, maybe not. Go here, click on alternative units, and that's what happens. In one click, you just change or convert between units. You want to see them both on the print? Here you go. There is another option, of course. As you know, we have the data here from the database. So what you can see here is that I have dual units. You see, this is the primary, which is inches. And I decided to have also the matrix alongside with the inches. And I can, by the way, I can drag it if this is what I would like to do here and put it next to the, oops, let me just move it here. And I can put it next to the inches. So now I have those 2 dimensions or 2 units next to each other. I can click here, save my grid view, or I can add different data from the database. You see, this is what we extracted from the database. Whatever checkbox, I put it here in the grid, but you can add and you can set up your own grid. Definitely relates to the role that you are running. Okay. Probably we will say enough at this point when we talk about downstream preparation. But now, what probably you would like to do is to go and create either final inspection or in-process inspection. So let me run quickly on those 2 options. If you have what we call in-process inspection, you just go here and click on manufacturing operation, and you see how many options the system enables to you. But let's go to quickly on in-process inspection. When we talk about in-process inspection, you see the system assume, probably right, that's my finished part. But I would like to do click on feature number 4, and this one, 924, and said, okay, that's going to be my operation 1. Again, I arbitrarily pick those features. It's not really what you're going to do. And I added operation 1 to the process, okay? And I can go and do operation 2 and operation 3 and 4. There is no limit on how many operations you can add, okay? And as you see on the right side, operation added, and on the left side, the print become color-coded based on the operation. But now, as you probably remember already, the pencil tells me, hey, you can do more than just this. So I can go to operation 1, okay? And I can call it, in our case, roughing, for instance, my first operation. And I can set up my work center if I have it in drop-down list, or you can edit here and create your own work center. And you can call this guy, hey, this is type of machining. You can add here whatever instruction, of course. Click OK, and you can do it for every operation. But now what you can do is actually go here and said, okay, I would like to create inspection sheet for each operation. So what you see here when we take, oh, this is operation 1, right? So the print is color-coded only for operation 1. I can go and create PDF, my operation 1, right? And here's my PDF. Okay, as you see it here. And again, I close it. I don't need to save it. It's already in the database. And I can create inspection plan for operation 1. But before I'm going to do it, just quick note for you guys. You see the nominal here, we don't have here. The nominal belongs to the final inspection. You can easily go and update the nominal to the roughing stage, and you can add material, change tolerance accordingly. A lot of things can be done. So I'm creating now inspection plan for my first operation. I don't need to click. I don't need to copy paste. The system knows exactly where I am. This is no paper process. So just one click, and probably in 10 to 15 seconds, I hope. That's my old computer. We'll see what it's going to show us. "21 seconds. Too long. Here is my operation 1. As you see here, 3 features. We get to actual, and we all set. Now, let's go to final inspection quickly, so we will not miss the reporting process. So I'm going to my final inspection. The same idea. I can go and create my PDF for final inspection with one click, as you see here. Okay, and I can close it, and I'm creating inspection plan for final inspection. Nothing to copy paste. The system knows exactly where I am, as I mentioned, and final inspection is created. Here is my final inspection. I hope you see it, guys, with all the list of what needs to be done, including the 2 notes that we decided to report to. If you remember, it was balloon, I think 25 and 26. And now we need to get the actual. From inspection manager perspective, actual can be from the, I would call it the most manual process, by getting the inspection results manually clicked in, which is an option. Then we bring the file into inspection manager. Or it can be completely automated from CMM machine, vision machine, any machine that generates digital data. We collect data from the shop floor with our inspection or data collection terminals called IMX IME that can be installed on any PC or tablet. And that's going to be real time. But when we bring inspection results, for instance, from your CMM machine, that can become completely automated, but I'm simulating what happened. So your CMM machine or vision machine generates CSV or XML or text file. It really doesn't matter. We bring the inspection results with a lot of data that relates to it, including who inspected it. As I mentioned, we manage users with the sampling, inspection tool, etc. When I'm clicking import, inspection results got to the database. Okay, and you're going to see right now the results in the database below here, which is supposed to be the bill of characteristics. Now it's bill of characteristics with results as created previously. And now you see the print color coded with the result. Green means pass, red means failed. Clicking on the red, you see immediately 16.1 is failed. And we have the gray that tells me, hey, those gray did not inspect. The purple one tells me that there is a discrepancies. The guy that runs the CMM machine maybe put the wrong nominal or the wrong tolerance. Before you get panicked, then you can check it out. And just to give you an idea, if you look on dimension number 2, you can see the 2.1 and 3 having results. The 2.2, which is the thread, There's no results because I cannot do it with CMM. So data collection on the shop floor, we're going to simulate it now here. Somebody put the gauge there, said, sorry, failed. That's my gauge that I use. Okay. Even the reason it's failed, click OK. And you can see that real time, it became red here and here. So all the process from 2D print to data collection. And now let's assume we have all the results. We need to create either first article report or multi-parts report. Doesn't matter. If you're going to create FAI, then it's one click. The system knows again where I am, what I need to do. You need only to pick up the right template that belongs to your customers or your internal process. Templates can be generated with our report generator in minutes. You just save it here and you have it. Clicking on the report, that's it. No copy paste, no clicking. The system encapsulated all the results, all the data from the starting point to the finish. And we minimize the use of the keyboard. And this is my first article report. And as you see, here's Form 1, Form 2, including the part material we took out from the print, and Form 3, as you see here. Okay, all the results, including the notes, and we are ready. So there are much more into it, including data collection, as I mentioned, SPC, which is integrated as well. There are many components, but I just wanted to give you kind of a high-level process, how 2D print really can be digitized automatically, and all the process now downstream become trusted without people interpretation. So from here, I would like to walk you kind of shortly to a case study, and I hope I will be on time with this process as well. Case study speaks about HiPro. HiPro implemented already almost the whole 4.0 using our solution. They are value leader in the machining, and they are manufacture very complex components and assemblies for the automotive industry. As you see here, they have 7 facilities across, I think, 3 states. They are employed above 700 employees, and they are in the market for 40 years using the most sophisticated and efficient CNC machining equipment. They have a lot of strong supply chain relationship with they are tier 1 and tier 2 together, and they're working with a very large OEM. I cannot disclose name, unfortunately. They were very early adopter of applying automation, even before Quality 4.0. But what happened when they used the previous technology, they have a huge issue and a big bottleneck because they make parts that having thousands of dimensions and GD&T characteristic on print. So their bottleneck forced them to do inspection process with CMM without using the balloon print and inspection plan, because it took them days and sometimes weeks. So they did it awkward. They did it the upside down or the opposite way. And then to match the balloon from the inspection results to the print took them another week, which is absolutely, I call it crazy. And a lot of other waste was there by doing a lot of engineering changes, manual data collection, a lot of copy paste and typing. So what they looked to, they wanted to improve their process, to remove their bottleneck. Their delivery time was always on time, but very expensive. So they look for, streamlining their quality management process. They would like to have a software that it's usable for the user. They will not have to communicate through the keyboard intensively. They look for trusted vendor, and they contacted HiQA. So after 6 months from the first day we started to train and implement their process, and we were involved in their workflow, we definitely increased the optimization of their workflow. And actually, a couple of months from the day they started, they automatically propagated inspection plan from one office to their 7 facilities. So instead of days and weeks, sometimes it took them a couple of hours, and all 7 facilities were ready to go with inspection plan and all the balloon done. And the inspection results, as you saw here, pushed back from different facilities directly to the same database and creating the required reports. Talking about 6 months later, which is actually almost today, they accomplished 350 big projects. Each project averaged 8 pages with 1,000 characteristics. Their largest project that they shared with us was 3,700 characteristics in 15 pages, which previously took them 11 days. With Inspection Manager, it took them less than 1 day. So probably some improvement we see here, let alone hidden costs on making mistakes. So where they are now, they meet much higher demand today with the same staff and the same resources. So they are much more scalable today. Busy time become a free time because they don't need to do any manual tasks. And this free stuff is now allocated to handle other opportunities. So there is much more put through with the same resources. They are now stated their productivity increased by 500%, talking about quality processes. And their next step is to automate data collection with the tablet, which they're looking to because they are going to replace their current manual tool to Bluetooth and wireless. They're going to apply the SPC and connectivity to enterprise system. And their biggest statement that we heard, we are now in control. So with that, first, thank you for attending. And I would like to transfer the presentation rights back to Jack.
Thank you, Sam. Now
You're welcome.
we have one question that was submitted. I think that you should be able to answer off the top of your head. Can you please share if the gauges and CMM instruments information is integrated with the software?
Oh, okay. Let me, with your permission, give me the presentation rights for a second. I can show you maybe in 2 minutes, so people will understand more on the visual way.
Yep, there you go.
If you are okay with it, thank you. I hope I didn't shut down Inspection Manager. I think we are here. Yep. So let me quickly walk you through this inspection tool. You see here measurement tool, but when we talk about managing inspection tool, let me, with your permission, shut down the system. We don't need this anymore right now. And I'm going to open it again. Can everybody see my screen? Now it's blue.
Yeah, we've got you, Sam.
Okay.
Yeah, you're good.
So thank you very much. So when you open Inspection Manager anytime, you're probably going to see a couple of, I hope I will see a couple of annoying boxes, which are blues. Oh, you see here on the right side. You can immediately see certificate alert. So each alert has linked to something. If I'll click on this one, for instance, so you can see that something pop-ups here and say, hey, your depth micrometer made by Mitotoyo is all data. needs to be calibrated on April 19th. So that gives you immediately the idea, yes, we manage gauges and other inspection tools. And when I'm going to measurement tools, and that's nice because it's integrated as well. Again, I could not show you everything. So you can see how we manage inspection tool with all the relevant information that you need on top of each measurement tool. But that's not all, because you can now go here on the setting, and for instance, you can go, you see default tool category enables you to assign inspection tool category to a certain feature. And from your inventory, once the system recognizes this feature on the print, it will automatically assign the relevant inspection tool. So well, nobody needs to guess, what you need to do with it. But again, you can overwrite it, because whatever we do automatically, the user has 100% control on the process. On top of this, the measurement tool can give you not just alert, it can do statistics, you can get reporting about historical use, what feature was inspected with what tools, and so on and so forth. So I hope I addressed this question.
Yep, and we have another question for you. I think we have just about time for one more here. Is the software cloud-based, or is it installed locally on premise?
Good question. The software installed in premise. Couple of things. First, we have many customers that, defense and aerospace, they do not like to have it on the cloud. But aside of the security issue, either it's the right concern or it's a psychology concern, it doesn't matter. The working with files that are sometimes hundreds of megabytes or more, then if you work on the cloud, performance may be very bad. You need to update 100 megabytes or 300 megabytes file. You send a packet to the, your cloud server. You may wait 20 minutes. By the way, one of the issues that Hypro, the case study that I described with the previous technology, which was cloud-based, they hardly suffer from that. So let alone security, it's practicality. So it's on-premise.
Okay, and looks like we've got time for maybe one more after all that. What configurations can the software be deployed in? How many different configurations?
Well, we have I call it 4 basic packages. And those 4 basic packages start as small as what we call a job shop. So you can install it, whatever you saw, it's job shop, can be installed on one computer, including the database, and all the functionality that you experience and more, you have it as a base package. From that, you can scale up to what we call the factory package that has floating license and centralized database. Now it means that you can install the software on different computers, and all the information that anybody works from any computer will be automatically stored and saved and retrieved from one database. Nobody is going to save it on any, folder on his local computer, etc. There is a third package that has more floating license, but also added more functionality like data collection, which is the terminal that can be installed on PC or tablet on the shop floor, and that's called Factory Pro. And then I think the last one is Enterprise, that has a lot of other capabilities, for instance, welding recognition and other components. But whatever package you're gonna pick or you're gonna use, in many cases, certain module can be added on. Let's say I need welding, but I'm not needing the Enterprise, but you can use it when you have even job shop. So I don't want to get into it, but the flexibility enable our customer to be from a very small scale up to a large enterprises.
Thank you, Sam.
You're welcome.
And take control back here. I'd like to thank everyone for attending today's session. Remind you that this is the first in a series of webinars dealing with Quality 4.0 challenges and possible solutions. For more information, you can contact HighQA at either 888-727-1266 or through email to info@highqa.com. And also want to invite you to visit our website, highqa.com. Thank you for attending.